Well, howdy everyone, it's Mr. Freiberg here yet again, and this is our next maths lesson for year 8, and this is continuing on our adventures that we started earlier in the week in the live lesson to do with algebra, and specifically today you can see there by the title that we are looking at expanding. So we're going to expand some algebraic expressions. We're going to use something called the distributive law, and specifically I'm going to show you an algebraic technique to work that out. If you're using your book, could you make sure that you write that whole thing down as your title and also the date which you should be viewing this, which is Thursday the 7th of May. If you have the notes, then you should have these pre-printed on the notes. And so, as well as, I should say, the learning intent and the success criteria, which is on the next slide. So there's the learning intent. It's to apply the distributive law to expand simple algebraic expressions that are of the form A multiplied by B plus C. And I'll explain to you what that actually means. Please take the time to write the learning intent down, and if you need to pause the video, please do. There's the success criteria, essentially the same thing. By the end of this lesson, you'll be able to expand algebraic expressions that look like that using algebra. Just to let you know, next week on Monday, we'll show you the second part of this, and you'll be working through that yourself, and it'll be to expand them using the area of a rectangle. But more about that next week. Let's start this lesson off with a little bit of a review. Now on Tuesday, we took our index laws and what our indexes looked like, the a cubed, the a to the power of 3, and we extended it a little bit further. We still had the idea, as you can see on the screen, of a base and an index, and you can probably identify that in this first term here, the y, that's going to be the base, and the 6 is going to be the index. But we also defined the base as something else. Now, in this case, it being a letter, we actually defined that in algebra as being a variable because the value that it can represent can vary. The index is still 6, and then we also on Tuesday defined something else, and that's the number that is multiplied by the base or the variable, and this thing is called, as you can see there, a coefficient. What I'd like you to do on this screen is I'd like you to pause it for about 30 seconds, and I'd like you to write the terms down that you can see on the screen, and I'd like you to identify the base of the variable, the index, or the coefficient. And I'd like you to do that for all of those. So pause the video for about 30 seconds, write down which is which, and we'll come back and we'll check the answer. Okay, so as you can see on my screen, I've drawn arrows to all of these features. There's a wee trick with the first one that I asked you to do, which was 18 hg to the power of 6, because hg combined is actually the base or the variable. The 6 up the top here is the index again, and the 18 out the front, that's the coefficient. The last two are a little bit more straightforward. 9g to the power of 2, the g is the base of the variable, the 2 is the index, the 9 is the coefficient, and for 5m to the power of 8, the m is the base of the variable. You've probably guessed it by now, the 8 up there is the index, and the coefficient is 5. Hopefully you'll be able to identify those features of some of these algebraic terms. What I do want to spend, or do want you to spend a bit of time on, is to go through this review. Now, in this review, you can see that there are 8 questions. The first 3 are just revising the simple index laws, and you shouldn't have too many dramas with those. These last 5 down here fall out of Tuesday's live lesson. Things like collecting like terms and then multiplying terms together. I'm not going to do any dividing just yet because we rely on multiplying terms when we do some expanding. Now I said there's 8 questions there, and I'd like you to pause the video, maybe for about 10 minutes. If you're using your book, can you please make sure that you write the questions out before you answer them? If you're using your notes, the questions are given on the notes and you can just write your answers in beside them. But as I said, pause the video, give it about 10 minutes worth of work, and then we'll come back and we'll check the answers. Okay, so that should be plenty of time for you to answer those questions, and let's have a look at the answers. Now the first three I've just quickly put the answers up there on the screen. Shouldn't really need to explain too much more about those. For the first one, the bases are the same and we're multiplying, and so the index law says that we need to add the powers together. And so I've got 4 plus 7 and gives me an answer n to the power of 11. Please make sure that you mark yours either correct or incorrect, and if it is incorrect, please fix it up. The second one, we've got the bases being the same, but this time we're dividing. And so we subtract the powers. So we go 13 take away 5 and gives us r to the power of 8. And then from last week, part C, we're raising a power to another power, and so I multiply the powers together, and this time 6 times 2 gives me k to the power of 12. Now those ones there, they should be pretty well, you should be pretty well all over those ones. Okay, those ones are pretty straightforward and you shouldn't be having too many dramas with those. If you are, please get in contact with me, Mr. Freiberg, as soon as you can, and we might be able to sort you out and give you a little bit of extra assistance. Let's take a look at the last 5 though in a little bit more depth. So what we're actually asking you to do with all of these questions is to simplify. Now remember I told you on Tuesday, simplify means we're going to make the expression smaller. So we can make this expression smaller here by collecting all of the like terms, and what I'm doing now is I'm actually circling the like terms. I can see that they're all like terms because they have the same base and they have the same index. The base is y and the index is 1, even though it's not written in there. Now, I circle them, and I also, as I told you on Tuesday, I also include the sign because the sign tells me what to do with these numbers, or what to do with these terms. So I start with 5y, I then add 8y, so that means I've got 13y so far, and then I take away 3y, and 13y take away 3y gives me 10y. That's the answer for the first one, 10y. Again, give yourself a tick if you got it right, cross it if you got it wrong, but please fix it up. Now part E is a little more tricky because we actually only have 2 like terms this time, the 9h and the take away 3h. But using the same sort of idea, I circle the numbers and the signs and it tells me what to do. So I've got 9h and I'm going to take away 3h. 9 take away 3 is 6. So it follows it'll be 6h. Now this plus 5, it's still part of the question. Even though I haven't circled it, I still need to write it down as part of the answer. So it'll be 6h plus 5. Now you might have already guessed what part F is going to be. Again, I'm going to circle the like terms. But you might have actually identified that we also have these 2 terms in here as like terms. So for different pairs of like terms, I use circles, I use squares, and I use all sorts of shapes. But the same sort of rule applies. I follow what the signs say, and I can collect the like terms. So with the negative 2a plus 4a, that's going to give me positive 2a. So I'm going to start by writing down 2a, and then I've got 6ab, and I'm going to take away 3ab. 6 minus 3 is 3. So the answer will be 2a plus 3ab, just like that. 2a plus 3ab. So those 3 there are reasonably challenging. Make sure that you've either marked it right, or if you got it wrong, fix it up. Now these last 2 down the bottom here, this is essentially what we're going to be doing today when we come to expanding. We are multiplying algebraic terms, and the good thing is, Yahoo, is that we can multiply any algebraic terms together. So something like 3m times 4n, hopefully you started by going 3 times 4 is 12, and then we just start listing out the letters. M times n is mn, so 3m times 4n is 12mn. For the last one down here, 6mn multiplied by negative 10np, well, 6 times negative 10 is negative 60. And we've got mn times np, so we could list it out as mnnp. However, if you've got that, that's okay, but as I told you on Tuesday, the correct way to write down n times n, we should know by now using index laws, is n squared. So your answer should be 60m n squared p, just like that. Again, give yourself a tick or a cross if you got those right or wrong. If you got them wrong, please make sure you fix them up. And do pause the video to make sure that you get these down properly. Okay, moving on. What is expanding all about? Well, expanding means I'm going to make something bigger. And what am I actually going to make bigger? I'm actually going to make the numbers in these expressions bigger. And what does 4 times g plus 7 actually look like? Well, it means I've got 4 lots of g plus 7. So in other words, I'm going to write g plus 7 4 times. And you remember, hopefully, what multiplication means. Multiplication is actually just repeated addition. So I'm actually adding all of those g plus 7s together. That's what 4 times g plus 7 looks like. And then I go through and I collect all the like terms. So for instance, I've got g plus another g plus another g plus another g. So I've actually got 4 of them all together. And I've got 7 plus 7 plus 7 plus 7, and that's 28. So the actual answer for that question is 4g plus 28. Now you could actually expand all of these out like that. However, what would negative 3h times look like? How could you expand something out negative 3h times? That's a little bit hard. So we come up with a shortcut that will enable us to get this answer again in 2 lines, and that is what we're going to look at today. This is what it looks like. Now you don't need to write any of these down because you're going to have a few to try yourself, but what I would like you to do is I'd like you to watch the screen very, very carefully. You'll notice that up here next to this little in this little diagram, I have some arrows drawn. And what I do is I multiply, because remember expanding is all about multiplying. I multiply this term that's out the front of the brackets by both terms that are inside the brackets. So I go A multiplied by B. There it is there, A multiplied by B. I then plus to that the value of A multiplied by C. And there it is there. So AB times AC. Let's take a look at some examples. It might make a little bit more sense. So let's take a look at the first one. 3 times A plus 9. I multiply the 3 on the outside by the A, the first term inside the brackets. So I'm going to write down 3 times A. I then multiply 3 by the second term inside the brackets. And now this is where it gets a little bit tricky because I'm actually going to keep the sign with the number. So that's plus 3 times positive 9. 3 times A is 3A, 3 times 9 is 27, and that's my final answer. I can't collect those terms together. They're not like terms, so that's my final answer, 3A plus 27. Let's take a look at part B together. Now this one's a little bit different because there's a negative in here, and I'm going to show you a controversial technique that I use when there's a takeaway inside the brackets. I'll tell you why it's controversial. But same sort of strategy. I'm going to multiply the number on the outside by that first term inside the brackets. I'm going to go 2y multiplied by 3y. Now you see the rule up here says plus, so I'm actually going to put a plus in there. And where does that takeaway, or where does that negative go? It sticks to that number. Because now I'm actually going to write down 2y multiplied by negative 6. And I think you should be able to multiply a positive by a negative. 2y times 3y. 2 times 3 is 6. Y times y is y squared. So 6y squared. 2 times 3 is 6. Plus, I've now got 2y times negative 6. 2 times negative 6 is negative 12. And so 2y times negative 6 would be negative 12y. There's your answer for the second one. 6y squared plus negative 12y. For the more advanced maths people out there, you might actually be able to write that more mathematically correct as 6y squared take away 12y. I'm happy with either one. Now I'm starting to run out of a little bit of room here. The last one, I'll do the same procedure. I multiply the first term or the term outside the brackets by the first term inside the brackets. So in this case, I've got negative 5g multiplied by negative 2e. And I add to that, multiply the term outside the bracket by the second term inside the bracket. So this time I plus negative 5g times 3. Oops, sorry for squeezing. Negative 5g times negative 2e. Okay, well, first of all, negative 5 times negative 2 is positive 10. And g times e will be ge, or, as I showed you on Monday, when you multiplying letters together, it's actually convention to write the letters down in alphabetical order. So it should be positive 10 eg. Plus, always plus in the middle. That's what the rule says up here, always plus in the middle. Now I've got negative 5g times 3, and negative 5 times positive 3 is negative 15, and so negative 5g times 3 would be negative 15g. I can't collect any like terms, so that's my answer. And again, for maybe a little bit more advanced people who remember that when you add on a negative number, it's actually the same as taking away. So 10eg take away 15g could be your answer. Remember though, I'm quite happy for you to get to that point there because that's actually correct. This one here is a little bit more mathematically correct, so I'll give it 2 ticks. So that's expanding. Take a moment to have a look at the screen. You might want to review these questions. You might want to pause the video and review these questions. But that's 3 examples of what expanding looks like, using the distributive law and using algebra. So now we have 4 that we're going to try together. Okay, if you have the notes, you have these pre-printed on the notes. If you're using your book, then please make sure you write these questions down carefully, maybe leave a couple lines in between so that we'll be able to do the working out. And the working out, as you've seen, is by drawing arrows to go 5 multiplied by 4, so the number outside the brackets multiplied by the first term inside the brackets, plus 5 multiplied by y, so the number on the outside multiplied by the second term inside the brackets, and then you can do the multiplication. Now I'm going to stop there. I'd like you to pause the video and I'd like you to see if you can finish that question off. I'd then like you to see if you can complete the other questions. 2 lines of working pretty much for each one. And once you've finished those questions, come back and check the answers. Should take you about 5 minutes. So pause the video now. Okay, let's check these answers. So 5 times 4 is 20. 5 times y is 5y. That's it. I can't collect them together. They're not like terms. So the answer is 20 plus 5y. If you manage to get that by yourself, give yourself a tick. Now the next one, we're going to multiply the term outside the bracket by the first term inside the bracket. So 4 times a and 4 times 3. Don't forget the plus in the middle. 4 times a is 4a. 4 times 3 is 12. I can't collect them together. That's my final answer. Now for a little bit of a challenge. What did we do about the negatives? Well, my little rule of thumb is to keep the sign with the number. So I'm kind of doing this. I'm kind of changing that into a plus and putting the negative next to the h like that. You can do that too if it helps. So when I expand this one, I'm going to have 2h multiplied by k. That stays as a plus. And now I'm going to have 2h multiplied by negative h. So that's how I'm going to do this one. 2 times h times k is just 2hk. Plus 2 times h times negative h. Now, this is a positive term and this is a negative term. So I'm multiplying a positive by a negative and that'll give me a negative answer. I've got 2 and I've got h times h, which will be 2h squared. Now, because you're beginners, if you got to that point there, well done, you got it correct. As I said, if you are a little bit more advanced with your mathematics, you would have recognized that that would be 2hk take away 2h squared, because remember, when you plus a negative, it's the same as just taking away. So well done if you got that one. For part D, again, I grab the number that's on the outside and I multiply by the two terms that are inside the brackets. With that takeaway that's inside the bracket, I can make that a positive, except negative y, so plus minus y. So expanding it out, I have negative g multiplied by positive g, plus negative g multiplied by negative y. Now negative g times positive g is going to be negative, because a negative times a positive is a negative, and that'll be g squared. Plus, I've now got a negative multiplied by a negative, which actually gives me a positive answer. Oh, yahoo! And g times y will be gy. So g squared plus gy. Well done if you got that last one. It's a little bit hard. Well done if you got at least two of those right, because you can actually expand some simple algebraic terms. If you got all four right, that's a fantastic job. But that's what expanding is, boys and girls. And that's using algebra. The technique is to draw some arrows, multiply the term on the outside of the brackets by each term inside the brackets. Please check your answers, and if you've made any mistakes, please pause the video and fix them up now. So let's just check in with how we're traveling. Success criteria. Can we apply the distributive law to expand algebraic expressions of that form using appropriate algebraic working? Geez, I hope so. Let's just check for understanding. 6 times 3 plus m. I'd like you to work that one out, and I'd like you to identify which one is the correct answer. It might take you 30 seconds. I'm not going to pause the video. I'm going to count to 30 in my head, and then I'm going to reveal the answer. So work it out now. I'm going to go 6 times 3 plus 6 times m. 6 times 3 is 18. 6 times m is 6m. Hopefully you put a circle around part C. 18 plus 6m. Next one, a wee bit harder. 7a multiplied by 2a plus 7a multiplied by 5. I'll count to 30, let you work it out. Seven a times 2a plus 7a times 5. 7 times 2 is 14. A times a is a squared, so 14a squared. Oh, it's either a or c. And 7a times 5 must be 35a, so I reckon it might be a. What do you think? It looks like everyone's agreeing. And then the lucky last one's got a bit of a negative in it again, except we're going to go 2 times a and 2 times negative 5. Now, where'd that negative come from? I'm going to keep that negative with the number. So 2 times a plus 2 times negative 5. 10 seconds to work the answer out. 9, 8, 7, 6, 5, 4, 3, 2, 1. Well, there's only one possibility there, and that's D. And hopefully you got something like that. So that's expanding using algebra. Out of the textbook, if you've got it there, if you're at school, you'll be able to use your textbook. We're in Unit 3.6 and it's called Expanding Brackets, and you notice that there are quite a number of questions there, 2, 3, 4, 5, 7 and 8, and I'd like you to do all parts of those 6 questions, and then there are 3 extension questions. If you're at home and you've got the class notes, you would have a copy of these on the class notes, or you may have accessed the actual document that just has the questions, the textbook questions individually. Again, like I've always said, please ensure that when you have completed these that you take a scan or a photo of your completed work and save it in the Dropbox on the Learning Place, or email it to me, whichever is easiest for you. So over the next few slides, you can pause the video if you're using the video. I have all of the questions. Here's question 2. They're probably the easiest set, and I would think that everyone should be able to get question 2 out. Question 3 is multiplying by some negatives. They are a little bit trickier. Just take a look at part C. You'll notice that there's only a negative out the front. That's the same as saying -1 multiplied by C plus D. Okay, so let's assume that that's a -1 out the front. Oh, that's horrible writing. Number 4, expand the brackets first and then collect like terms. So number 4 is starting to get a little bit harder because it's combining what you looked at today with expanding with what you looked at on Tuesday in our live lesson with collecting like terms. Okay, so number 4 is a bit harder. There's number 5. Again, it's expanding and collecting like terms, and then we start to get into a little bit of problem solving. But as I said at the start, I think everyone should be able to do these questions. 7 and 8, expanding and simplifying gives you what? In number 7, it's a multiple choice. And then in number 8, as a little bit of an intro to our next section on expanding these out, write an expression for the area of that rectangle. Now you've got to obviously remember the area of a rectangle is length multiplied by width. So you're actually multiplying together the 3a minus 2b, and you're multiplying that by 2a. And you should be able to expand that pretty easily. Same with number 11. The only thing that's missing is the rectangle. So draw a rectangle in. 13 and 14 on the screen here, these are the extension questions. So they're a little bit open-ended, as you can see, and they're a little bit harder, and they might take you a little bit of extra time. So if you spend a whole lesson on this materials, I believe this video is taking about half an hour, so you've still got about 40 to 45 minutes where you can continue working on this, plus some extra time for your homework. As I said, make sure when you have finished that you email me a copy of your work or submit it in the Dropbox in the eLearn classroom. So for today, let's make sure that we can expand algebraic expressions using algebra. You've got a few days to work on that. On Monday, we'll show you pretty much the same thing, except we'll be using the area of a rectangle to work it out. I look forward to speaking with you then, and then catching up next week for our live lesson. I hope you have a fantastic rest of your week and enjoy your weekend. See you guys. Thank you.